great effort. Thank you so much. And I think that now it's time for Evdokia to take the floor. You're welcome. Thank you so much.
So good morning, everyone, again. Well, in the program it says I will give a keynote speak, but I just gave one 5 minutes ago, so it doesn't make sense. I wanted to just welcome you to this workshop and just say a few things in the context of this workshop and also Water Projects Europe. As I said this morning, I work in REA, and in REA we are implementing the work program of Horizon 2020 and Horizon Europe. Our unit focuses on the part on environment, circular economy, zero pollution, and also the legacy part of Societal Challenge 5, that was environment and climate action, resource efficiency, and raw materials. So what do we really do? In REA, we take care of the full program management cycle. So from the information day for the topics, then the evaluations, then the granting process, and then the monitoring the projects. And also a lot of collaboration and communication and dissemination events such as the one of today. And what is important is that these activities is about gathering intelligence from the projects, gathering evidence that can feed into policy making, either supporting policy implementation or further policy development. So ever since 2014, with Horizon 2020, we started a push for putting a focus on project clustering. Why do we put a focus on project clustering? First of all, is to have the projects inform each other of what they're doing, and then to foster collaborations between them, but also to avoid overlaps between the projects. And this, we found that it leads to a higher impact of the results of the projects by the end of the project, and a better outreach of the projects. So some of our clusters are top-down, so even in this topic of the work program, it's required that you cluster, but many of our clusters are bottom-up. So it's the projects that originated, and then we have some average situations. For example, I think for the zero pollution for water cluster, it was not required, but it was suggested. Synergies recommended. So we as an agency, we wrote to the project and say we suggest clustering activities, But then the projects took this further, and then Water Europe is now the umbrella for the zero pollution water cluster, and we have 7 projects there. But it's possible, and I'm thinking this now, Andrea, that maybe other projects could be added to this cluster as with the next work program if we have relevant projects. And it can also become like a living cluster. So in the early years, as an agency, as ASME first, and then as REA, we drove this process. So we organized the cluster, we organized the meetings, or the governance of the cluster. For example, with ICT for Water cluster, we had a big governance, and we still do. But as the years went by and the community grew and the projects and the, let's say the participants got used to this, now the projects are taking the lead on this. And we will support the links to the policymakers. We will disseminate the outputs of the cluster. We will raise awareness. We will bring the policy officers to the meetings. But we let the projects organize and drive this process because that's where the experts are. So we think it's more efficient this way. And we have co-organized in the past, as ASME or REA, many events with Water Europe and some clustering events. It started with the ICT for Water cluster and a Digital Water Action Group. And I think it was in 2019, Andrea started talking to me about Water Projects Europe. And in 2000, yeah, I said, yes, we think it's a great idea because you're already a community and your members are all, most of them are part in water projects, so you can bring them together in a very efficient way. And ever since, I don't know how many events you had, Andrea, maybe 5, 6, or maybe more. But it's usually co-organized, like today is co-organized with IDRUSA. And I think you co-organized another one. Yeah, one of the first ones. Is co-organized with a project, or maybe more than one project. And we think these activities are of high value. Now, what can project clustering lead to? I mean, it can lead to collaboration between projects. First of all, on exchange on the technical task, exchange on the demonstration cases, but also it can have some collaboration, some synergies for engaging stakeholders. So you can join forces, the projects to engage stakeholders. And then you can join forces to create a little workshop to come up with some conclusions on a thematic area from the projects. The projects sometimes have joint outputs. It can be a joint policy brief, it can be a joint report on their case studies, or it can be a joint, what is the advancements of this group of projects, or it could be a joint report on the research policy gaps, which can be very useful, and it will, if provided in time, it can fit into the next work program. So all of these inputs are valuable for policy making, policy design, and this is what we consider feedback to policy. It's not from, it's feedback from the project to the commission, and it's also feedback from us as agency that we attend your events and we pass these messages to the commission. This is really a collaborative process. It cannot be done by one actor. So I think this is why having the clustering events, the clusters helps this. It's a collective effort. So I'm happy to be here today in this workshop. And last but not least, I wanted to say a few things about Living Labs. I think you will be talking about it today. Also a collaborative process. I think this is a concept that is inherent to water, the concept of Living Labs. Maybe it has been maturing over time. Since 2014, we were talking back then about systemic eco-innovation. We were talking about co-creation, and then the concept evolved further. I think it's also a concept that is encouraged, or let's say is compatible with water policy in relation to water management. And also that maybe, and I'm waiting to hear your views today, that is very closely linked to circular economy. The different aspects of circular economy can facilitate the deployment of circular economy. So I'm looking forward to listen to your presentations.
Thank you, Evie, and I'm glad to say that we have a very nice mix of projects dealing with the municipal sector, the industrial sector, and the agricultural/rural sector, all within the umbrella of water. So yesterday night, after the first day of the conference, I started to draft my presentation, and I decided last minute not to put anything about the demonstration sites, since this is something that is covered within the conference. So my focus will be more on the horizontal activities of IDRUSA project, together with a couple of slides on the key findings of the project. To start with the let's say, introductory part, IDRUSA is finishing its journey this month. It was a 5-year project, started 5 years ago. I can't believe it's finishing. It's been a long journey with 28 partners on board. It was funded within the call Water in the Context of Circular Economy, together with its sister projects of NextGen and Project O. And we have a number of innovations which are implemented at full scale in 6 demonstration sites in 3 Greek islands, in Tinos, Mykonos, and Lesbos. But before going into the actual details of the project, I always like to share this slide that shows the importance of our project, of Idrousa, with respect to EU policy. There are not so many projects that target on small-scale systems, on decentralized areas. And Idrousa is targeting exactly this, Mediterranean water-scarce remote areas. And this slide is taken, this figure is taken from the recent Urban Wastewater Treatment Directive evaluation. And on the y-axis is the population equivalent of loads, BOD, nitrogen, phosphorus, coliforms, that currently, or back in 2019 when it was made, enter our water bodies in Europe and could be avoided. And what I've circled with yellow and orange is what Idrousa is targeting to remove from our water bodies and recycle or recover. So you can see, although small and decentralized is often neglected, it is an important load to European water bodies. So we need to do better there. And I'm sure many of you have seen this slide again. It's the Idrousa water cycles, what we are targeting to valorize non-conventional water sources, which includes wastewater, rainwater, stormwater, vapor water, seawater, and we close the loops having different uses. All of our demo sites have at least agricultural irrigation as a final use, at least that, which is the prime consumer of water in Greece, but also within many Mediterranean countries, over 70%. And we have been successful in showing exactly that our solutions can be integrated to recover not only water, but also recycle nutrients, recover energy, and use these resources for the benefit of the local society. So some key messages that I drafted yesterday, trying to summarize a little bit the work in one slide, is that we have shown that a completely circular wastewater management system at decentralized level can be sustainable and economically viable. And I'm saying this because at the decentralized level, the monitoring cost can be a big inhibitor to the whole circularity concept, because you don't have economy of scale to support what you are doing in terms of innovation. So, for example, if you have an endless list of parameters to monitor, this is increasing your cost, and it could make water use non-affordable, and this is even more difficult and critical in small scale. What we have able to show is that by coupling anaerobic treatment with constructed wetlands and UV disinfection, you are able to get Class A water. And in terms of the BOD and the solids, this has taken the ETV, environmental technology verification. We got it a couple of months ago, and I think it's the first wetland system treating domestic wastewater that gets it in Europe. And why this is important? Because we don't need to add a tertiary filtration step. Both the Greek water reuse law and the European regulation, they say that if you go for Class A, unrestricted irrigation basically, you need to add tertiary filtration. We achieved this without it, and this is good evidence, solid evidence that this can go. We have shown that through the fertigation practice, We can enhance biodiversity. We have an increase in the nematodes. We've done a 2-year investigation of the soil aspect of the soil health. And in terms of nematodes, we have seen differences and increase in the production of yields. We have implemented bioswales to cope with the rural floods, so preventing the use of rural floods in agricultural areas. And we have seen that with a solar desalination process, we can achieve very low salts in the treated water. Of course, we have many other points, but I try to highlight some that I think are very critical. One of the key aspects going on to the horizontal activities of the project is the multi-sectoral water circularity assessment framework we have developed that it links the water, the energy, the industry, and the agricultural side. And this framework was also published in Water Research, is actually used in tendering procedures of big industrial companies like Jacobs Water. In terms of policy support, we have provided 2 policy supports to the European Green Deal and to the evaluation of the Urban Wastewater Treatment Directive, the second one targeting on small scale. And I think our voices were heard because in the proposal, in the new proposal, they are decreasing the size that you need to have treatment and storage system to 1,000 rather than 2,000 population equivalent. And the relevant paper. We have a low-cost monitoring system that is on the market. This is very important for small systems that you don't have. You don't have the luxury to have high-tech systems for water monitoring, particularly when the customer is a farmer. And we have done feasibility studies for 25 replication sites across Europe. We have a couple of sites where we have gone beyond our contractual obligations. And in Italy, for example, in Gorgona Island, the system that was developed in Lesbos is funded by Italian state money to be implemented in Gorgona Island. And we have shown through our analysis that the payback period for the Idrousa solutions is, depending on the solution, between 3 to 7 years. 7 years may seem quite a long time, but consider that we're talking about small-scale facilities and for the benefits of the local stakeholders. And Idrousa has given feedback to many other projects. I don't have the time to go through all these projects that I've listed here, but in one way or another, they have taken elements of Idrousa, either in terms of the technology side, of, for example, industrial application in Axel Water, which is will be presented, or in terms of the WEF Nexus approach and the SUR Nexus that is funded by the Prima Foundation, or in terms of the nature-based solutions in Cardimet, which is starting in September, and there is also here a presentation, or in terms of rainwater harvesting. So we have many other projects which have linked and are taking valuable feedback from Idrousa. And because there was a comment in the previous session that sometimes maybe they start from scratch, but in this, you can see here that there is a build-up and a follow-up that other projects can capitalize from what we've done in the project. So thank you very much. That's all from my side.
Many thanks, Simos, for the presentation. I think that's we should go, through the Idrousa outcomes and concepts, many times also in the future, so to drive other projects, I mean, to take inspiration from what you did. It was really, and it's really outstanding. Now is the time, I mean, to go to the next project. Next Gen project is not active any longer. Well, yes and no. Let's say that Next Gen project closed in November 2022. It's an Horizon 2020 project, which Water Europe was honored, I mean, to be a partner. But it is still, I mean, alive somehow to the marketplace. And then we're going to speak, I mean, later on about the marketplace, which is one of the outcomes of the project. But the Next Gen project has, I mean, something that should be really shared also, like they do, I mean, in the long run, because just from the beginning, or just from the name, next generation, what is next generation about water, what we are going to do, I mean, with water management and all the challenges that are related to. So, Cleo, you're welcome to take the floor, please.
Thank you, Andrea. Good morning, everybody. My name is Cleo Monokroussou. I'm a researcher in the National Technical University of Athens. And I would like to share with you today some of the knowledge, the experience, and the insight that we have gained while working for more than 4 years in the Next Gen project. A project that is part of the circular economical, like Hydrousia, and is also an active and willing supporter of the EU circular economy package and a contributor to a future European roadmap for water in the circular economy. So what was the original scope of Next Gen? This was to develop and mainly to demonstrate novel technological, business and governance solutions for water in the circular economy in 10 large-scale demonstration sites across Europe in 8 countries, and to develop the necessary approaches, tools, and partnerships to transfer and upscale these solutions. And I would like just to share some the main results that we have gained through this work. And mainly, we started with building demonstration sites, designing, implementing, and testing 26 circular water-related technologies in 10 sites across Europe to actually close the water cycle, but also energy and material cycles. This was done to provide evidence that technically wastewater can be transferred into valuable and high-quality products. And to document and record this knowledge, we created a technology evidence base which was populated with the demonstrated results, but also quantified impacts and lessons learned. And what we did after building these sites, we would like to, of course, assess them. And we did detailed assessments that provided evidence about environmental and economic performance on the risks that were identified and provided improvement options for them. For example, in the life cycle assessments, we proved that the circular economy solutions can lead to a lower environmental footprint, and we also assessed the microbial risk to illustrate a safe implementation of water reuse applications in almost all tested configurations. And we did economic assessments of these solutions that, although presently few of them were cost-effective in terms of climate change, this is expected to improve. And this was shown as they would be further developed, upscale, and reach a market maturity. And when we assessed these solutions, we tried to communicate them. And we created an engaging environment through a series of systematic and holistic activities. We conducted 37 engaging communities of practice with more than 300 representatives of stakeholders and policymakers discussing the opportunities, but also the challenges of implementing full-scale projects, expanding the solutions, and bringing them to the real world. We also developed two very interesting tools, the AR application for the circular economy and the next-gen serious game, both of which were to reach out to the public and to engage citizens to enable a transition to a circular water economy. And to improve our communication to the public, we of course needed to go and study the public through a very large-scale survey that it was conducted in three countries, in the UK, the Netherlands, and Spain, in which we assessed the social acceptability for the circular solutions, and we found that about 70% of the respondents supported the use of recycled water for potable purposes, and 80% agreed with the use of recovered nutrients to grow food. And this is interesting because the percentage of people not agreeing with this rather extreme outcome is relatively low. And after communicating this message and engaging the stakeholders, we explored new business models and support market creation to foster a circular economy development by moving from a linear model to a circular economy approach. This was done by establishing a circular business canvas and identifying 23 circular value chains and also for selected circular solutions, we developed market assessment and business plans. And it was very good result that we managed within the course of the project to launch 3 spin-offs that would fully pursue the potential of several solutions of our tested approaches in the real world. As was mentioned before by Andrea, we had a major achievement in this project, which was to develop an open innovation circular economy ecosystem around water, the circular economy marketplace, which was finally adopted by Water Europe to ensure the long-term sustainability. And this platform brings together solution providers and problem owners that intend to turn their processes to circular. And it serves also as a meeting point and engaging place for stakeholders and policymakers that would like to seek for solutions in the fields of water, energy, and nutrients. And the good news is that this platform, this environment is still alive and keep updating itself through the Be Water Smart and the Ultimate projects, and new knowledge is entered and further enhanced with case studies, products, and technologies. And in the next presentation, we will elaborate more on that. And coming up to a conclusion about the main next-gen outcomes and achievements, I would like to say that I think we have unlocked the potential of the circular economy in the water sector by successfully testing and optimizing innovative solutions that close cycles of water, energy, and materials. We have provided evidence towards the transition of a circular approach, including the societal acceptability, water value chains, business models, and supportive policy and regulations. Of course, we have launched the online platform for hosting products and services, assessment tools, and best practices. And finally, we have informed relevant policy as to the clear need for better aligned with EU directives that incentivize circularity and mainly simplify the processes of less costly routes to market for the recovered resources. So I will stop here and we can have a later discussion or questions now if you like. Thank you all.
Thank you, Cleo. Very interesting and fascinating. And I think the key message is the marketplace is open, right, for all projects to join. And as the DRUSA coordinator, we are looking forward to this, to support this. And it's a good follow-up, I think very good follow-up of the project. So now we have the pleasure to have here with us Christos Makropoulos, professor within the National Technical University of Athens, Department of Water Resources and Environmental Engineering of the School of Civil Engineering, to present the ultimate project. Christos.
Thank you very much, Simo. Indeed, I will be presenting a snapshot of where we stand with the ultimate project. Now, the ultimate project hasn't finished yet, so we are about midway, let's say, which means that I won't have final deliverables to show, but hopefully I will attract some attention to what's going on. The project is about industrial symbiosis. I will explain a bit more. It's coordinated by KWR. Herr Brandenberg is the coordinator, and I am the technical co-coordinator. And with this hat, I have the pleasure to present some of this to you. I don't have to convince you as an audience that the linear production, consumption, disposal chains make Europe, but especially its industries, in the context of ultimate, vulnerable to, of course, climatic changes. Water resource depletion and changes make that a problem. But they are also vulnerable to competition, industrial and commercial competition for limited resources, raw materials. And indeed, as an important side effect, we also have environmental degradation because of the waste streams, which suggest the need for ever more increased investment by the Union on pollution control. Now, all these are challenging problems, and they are notoriously difficult to solve on their own. But what if, moving into a circular approach, we could actually solve them all at once, turning wastewater into resource, extracting water, energy, nutrients, and indeed high-value added compounds from the waste stream, and therefore future-proof European industries in terms of the markets as well. By the way, when we were describing this challenge, the main problem was market volatility in terms of raw resources and energy. But since then, geopolitical changes have, as you know, challenged our supply chains to the extent that now we are thinking of circular solutions and autonomy for EU industries as a matter of safety and security of the Union. So I would say that since we began conceptualizing this, the importance of autonomy and industrial symbiosis in European industries has grown massively. So this is the promise, and this is where industrial symbiosis comes into play. This is really about reusing wastewater, and compounds within the waste stream between co-located symbiotic industries. And of course, if you do that, and this is this nice schematic is a real example of a place, Kallenberg, and this is an industrial area in Denmark, where in fact the term industrial symbiosis was coined years and years back. And I'm happy to report that Kallenberg, the industrial park, is a partner in Ultimate, and they are actually extending their work. Kallenberg is currently expanding massively. It's doubling its size, and it has committed to use Ultimate as the technologies in Ultimate and the knowledge in Ultimate as the vehicle to achieve this next step of this iconic industrial symbiosis global lighthouse, if you like. What's very important with this idea is that not only do we decrease environmental impact, we secure local flows of raw materials, locally available raw materials that we don't import from China, say, but we also create local non-relocatable jobs, direct and indirect jobs, and we see that in Kalburg and other places. So very interesting as a concept. So what we did in Ultimate, what we are doing in Ultimate, is we are working towards a rather ambitious aim to become a catalyst of a particular type of industrial symbiosis, which we termed water-smart industrial symbiosis. We hope that this term will be coined and used across other work, in which water, and indeed wastewater, plays a key role both as a resource per se, the water part, but also as a vector for energy and materials to be extracted, treated, stored, and reused within a business-oriented industrial ecosystem. So to do that, we have a number of cases. I will show you some of them, or at least a snapshot of where they are located in a map. We are developing quite a lot of technologies, hardware, treatment technologies for key industrial sectors. We also develop a number of very interesting and ambitious digital tools. For those who know me, know that the digital part is closer to my heart, so I'll give you some examples of these tools in the next few minutes. But we also work on novel business models. We have a very interesting, I think, work on that. Around water leasing, equivalent to chemical leasing. It's a really groundbreaking concept. And also we work with stakeholders in a rather innovative way, exploiting work at the cross-section between art and technology. And indeed, quite a lot of the work is geared towards guidelines and policy, as Evi suggested. And we are leveraging in this project much more than just technology. It's not about technology. Well, it is also about technologies, of course. But it's also about having the paradigms, the different paradigms, the tools, the ecosystem around the water marketplace that Cleo mentioned earlier on, and Andrea, a global outreach and a really strong partnership. So we work on the ground. These are 9 high-profile water-smart industrial symbiosis cases, starting from Nafplio in Greece and going all the way up to Kalundborg, as I said, in Denmark, and from Tarragona in Spain all the way to the Glenmorangie distillery in Scotland. I'm emphasizing this for obvious purposes. And within this set of cases, actually we have also a wide range of symbiotic arrangements, different symbiotic arrangements in different cases. So there are cases where industries and municipal water companies work together. So Spain was one of these. Or cases where co-located industries co-own a water company that manages the water. Kalundborg is such a case. Or indeed, a much more open, let's say, market type of approach where industries work with commercial companies. And these commercial companies can be anything from multinational corporations. So we have Veolia, for example, managing quite a lot of the industrial parks in France, all the way to SMEs, like we do in Nafplio, for example, where a very small SME is really managing and creating business with local fruit juice companies. So quite a range of symbiotic arrangements to also learn from the differences. And in these cases, we demonstrate how and where we can better target water demand, energy consumption, and wastewater generation at both an industry level, but also at the industrial park scale. Cases where treated municipal wastewater is the resource of choice for industries because direct water recovery from rivers is much more polluted. And indeed cases, quite a lot of cases, where the real rich resource is the material hidden in the waste stream, including nutrients, of course, but also high added value compounds like polyphenols. And these are very expensive resources that can be used in downstream symbiotic industries, either directly by the industries or marketed through third parties. Now, I will very briefly scan through 2 or 3 of the digital tools, simply because I'm that sort of person. One of the tools that we have developed, actually this is something that we have been developing and building on over several years, is a platform that allows industries, both at the individual industry level but also at the industrial park level, to map their performance and optimize their performance in terms of industrial symbiosis. We call this the KPI tool. It's built on our proprietary NESI technology and has open APIs that can link to essentially any sensor type of system deployed, customizable dashboards, additional features, including analytics, machine learning analytics that extract knowledge from this wide range of information that is coming from the field. Now, individual industries, you may remember, they all have a form of control on their own, but parks, industrial parks, well, they are not controlled by the control systems. So this has been a bit eye-opening, I would say. So this was the real-time part, if you like, of the story. But of course, before you go real-time and monitor and optimize symbiotic loops, you need to create them. And this is where our matchmaking tool comes into play. It's again a digital platform that allows a number of industries putting in some information to gauge and identify the best or the most cost-effective symbiotic routes, let's say. And of course, the best routes and the best matchmaking opportunities are related to prices of raw materials, are related to legislation, so we can check how differences in industrial legislation would affect the creation or destruction of these loops. So this sort of thing, I think, is very interesting. We are also exploiting, because this information is notoriously difficult to find, the detailed cost information on this industry is notoriously difficult to find. But we have developed a very interesting concept around the Sherwood plot methodology that allows us to calculate very accurately recovery costs and selling prices for this. Finally, last but not least, I would say, the water marketplace that Cleo also mentioned, and Andrea. This is now, we have taken it up, as it were. This is a prime example, actually, of projects working together, not creating things from scratch, but moving ahead. And in this water marketplace, which is live, and you can link to it and register in the link, the web link here. We have already inputs from a very big number of EU projects, everything from technologies to products to cases to lessons. It's a hub of knowledge, but also it's a meeting place between, let's say, problem owners and solution providers. Now, the marketplace doesn't sell materials. I want to clarify this. It's not about selling water or selling raw materials, this marketplace. It's about selling the technologies and services that allow this to happen. There are other marketplaces that attempt to do the material exchange. Actually, water mining that you also mentioned develops a similar platform. But so this is this one-stop shop. And indeed, the fact that Water Europe has adopted this and curates this means that it will not end, not even when our project and this ultimate project ends. So this is, I think, very good. I talked about communities of practice, and I also emphasized the fact that actually we are very proud that we also explore and exploit new, very exciting opportunities that come from, and functionalities that come from an intersection between arts and digital technologies. So we use augmented virtual reality. We create multi-use play spaces with our colleagues in Norway. We create immersive narratives that allow users to explore what could be this industrial symbiosis about and how it could happen, although the public is seldom ever present or could be present in industrial settings. It's a challenge, that. And we have opened our services already to a wider audience. We have opened a call, which is now closed. Just a few weeks ago, we closed the call for free industrial symbiosis advice. And we have chosen, as per our contract, 3 very interesting cases from the applicants, and we are starting, next week, we are starting to do free, paid by the project assessments of industrial symbiosis for 3 entities, including, as I said, the Kallenborg new development. We consider this a big win because this is the definition of industrial symbiosis, and the fact that Kallenborg has chosen Ultimate as the vehicle to proceed to this next level and invest millions and millions of euros is, I think, a big success. We are very excited about this. And of course, we don't work in a vacuum. Evie mentioned already some of these projects. Idrusa is why we are all here. The ICT for Water cluster is where we also work, and indeed, Water Europe is, for us, not just a partner. It is a platform, a strategic partnership, and we consider it a focal point, if you like, of all this work. So watch this space, as it were, as the saying goes. Thank you very much.
Thank you, Chris. Very much appreciated. And Water Europe is honored, to be a point of reference for the projects, for the practitioners, for the researchers, for the companies that want to transform research and innovation into solution. Wants to be a focal point for the territories that want to deploy innovative solutions. And to the marketplace, I think that we can also provide an additional very good service, to the water community, to the water sector related sectors, communities, in order to address the challenges of the water and related areas. Now it's time for a coffee break. Since we are a bit behind the schedule, the coffee break was planned for half an hour. May I ask you to be back in 20 minutes? That would be great. So let's keep, stay connected to the ones who are following us through the web. We'll be back in 20 minutes. So it's also coffee break for you. Thank you so much.
are like a different language. Because we made it as well like accessible for deaf people, like the subtitles and all the description.
This one is very decided.
I
also write my name because I
So that's Mykonos.
This is Mykonos. This is the Hydros Brigade. Έλα Μαριανή μου.
Okay. Good.
Το καλό θα είναι στην κυρία σου γιατί
E poi diventa adesso.
Πειραιώς 100, ναι, απλά έχω βάλει μέσα, έχω βάλει τώρα είναι βάθος. Και να μην ξεκατευθύνει και το έξω είναι βάθος. Ναι, και να περιμένει την Πειραιώς και θα το παραλάβω εγώ. Μπορεί να δω δηλαδή το χάρτη πώς έχετε. Είναι πληρωμένο. Πιστεύω... Τώρα σε πολύ κάτι είναι... Οπότε, ευχαριστώ. Από το site της Chrome, λες, από το site της Chrome. Chrome. Υπάρχει ένας τύπος που φτιάχνει τσάντες artificial. Πολύ καλές. Και αδύνατο. Κορδούρα. Κορδούρα που είναι το ίδιο ματήριαλο. Θα δούμε και όταν υπάρχει χρόνο.
Okay, now it's on, it's on. Thank you so much. So after a coffee break, which is always pretty dangerous because then it's difficult to chase people to go back to the meeting under this wonderful sun of Athens today. But we go ahead with the project presentation, and I would like to call Vasilis Fortsas to present Axel Water, which is another amazing project. And well, I mean, please, the floor is yours. You're welcome to present the project. Thank you.
Good morning, all. My name is Vasilis Fortsas, and I will be presenting. Sorry. Good morning. My name is Vasilis Fortsas, and I will be presenting you the Axel Water project, which was mentioned earlier in Simo's presentation. And of course, would like to thank Simos for the invitation to participate in this conference. So, the Axel Water project, the whole title is Accelerating Water Circularity in Food and Beverage Industrial Areas Around Europe. It is a project that began back in November 20, deep in the COVID quarantine, which we've all forget about now, of course. And it's a project that was supposed to be, the duration of which was supposed to be 48 months, but due to COVID delays and such, we've already requested and we got approved a 6-month extension. The coordinator of the project is the company I'm working against, and the budget of the project is around 9.5 million euros. So, the problem statement of the Axel Water project: the food and beverage industry is the European Union's biggest manufacturing sector in terms of jobs and value added. However, the sector must become more environmental friendly and produce more with less for feeding a continuously increased population. Some numbers I'm going to be referring is that, as we said, the F&B, the food and beverage industry is one of the biggest in the European Union. At the same time, it's one of the most wasteful industries, and it's very water and energy intensive. As much as 11% of global water resources are consumed by the food and beverage industry, and food processing needs 28% of the total energy used for production. In addition, the factors of water scarcity and the ever-growing population on the earth must be taken into consideration. I have here some numbers that are quite alarming, and I also have a small introductory video that, if we have the time, I will be reproducing later on. For example, you can see here that 1 glass of wine or 1 glass of orange juice requires 150 liters of water. 1 kilo of apple requires 700 liters of water, and we go as much as 1 kilo of chocolate that requires around 24,000 liters of water. So the advice is, do not eat chocolate, of course, apart from health reasons. So the Axel Water main objective is to optimize freshwater consumption in the said industry under a water waste energy nexus by introducing beyond state-of-the-art water reclaiming, reusing, and artificial intelligence-enabled monitoring and control technologies. What we will be focusing on is 4 main pillars: water, waste, energy, and smart monitoring and control. Here I have a slide of the work packages. Actually, I will be presenting later on that in this project we have 4 demonstrators. We have also a work package of monitoring system, a work package of evaluating said demonstrators, a work package about business cases, exploitation strategy, and so on. And of course, the work package is dealing with dissemination and project management. Now, as I said, we have four demonstrators in this project. We have an industrial symbiosis demonstrator in Greece. We have a meat processing demonstrator in Spain. We have a tomato processing demonstrator in Italy and the fish processing demonstrator in Iceland, which we visited last week, by the way. So, some common targets of the demonstrators include water and energy saving, reducing the environmental footprint, reducing the amount of resources wasted, reuse of water, energy, and byproducts, and production of new ingredients and products. The industrial symbiosis demonstrator, like I said, it's in Greece. It's located in the industrial area of Patras. In these three food companies, food and beverage companies participate. It's Friesland Campina, Hellas, which is a dairy industry. It's the Athenian Brewery, which produces most beers here in Greece, and it's Rezos, a Greek food processing company. In addition, the Technical University participates along with ICCS, Dignity, and of course us, Agenso. The main resources available for this demonstrator are wastewater, acid waste from the dairy industry, and spent grains from brewery. Moving on to the tomato processing demonstrator in Italy. The main resources and byproducts available are wastewater and tomato processing wastes. The partners in this demonstrator are Prodal from the University of Salerno, Calispa, which is the tomato processing factory, and ANICAV, which is an association of tomato processing companies in Italy, which they seem to have a great interest in the project, which will be good for the later stages. Moving on to the meat processing demonstrator, the main resources available are wastewater and solid waste from meat processing. Participating in this demonstrator are the University of Vic, laboratory from there, Mafrica, which is the meat processing factory, and I've forgotten it here. It's Innovac, which is a cluster of Catalonian meat processing companies. Lastly, the fish processing demonstrator that, as we said, is in Iceland. The main resources and byproducts available are side raw material and residual ingredients from processing water and recirculation systems. Participating in this demonstrator are two fish processing companies from Iceland, which are very difficult to pronounce, so I will not embarrass myself. The University of Iceland and Matisse, a researching company in Iceland. The current status, we're currently on month 32, a little after the middle of the project. The systems and user requirements have been gathered. The 4 demonstrators have been designed and all systems have been installed. Data gathering has begun as of last month, and one important thing to mention is that we've already had some contact with a tomato processing company here in Greece, Kiknos, it's one of the oldest ones, so as to replicate the tomato processing demonstrator after the project, and if the results are good and it is so desired by the company. I have an introductory video here. Simos, if we have the time, I would like to. Yeah, it's 3 minutes, so.
Imagine a supermarket aisle where every good for sale will have a label with the amount of water spent for its production. How is that even possible? The food and beverage industry is one of the most wasteful industries in the world, while being water and energy intensive. As a matter of fact, 11% of global water resources are consumed by the food and beverage industry. Various everyday goods consume huge amounts of water in their farm-to-fork journey. On top of that, food processing makes up for 28% of the total energy used for production. Moreover, let's not forget the high pressure that the food and beverage industry experiences due to the growing population and the water scarcity. In order to guarantee food safety, the food and beverage industry is forced to adopt proper water management techniques. Axel Water is an innovative action project funded by the European Union, which promotes a holistic approach for the efficient water, waste and energy management, including the use of beyond state-of-the-art monitoring systems and technologies for the reduction of the environmental footprint. The Axel Water Consortium incorporates partners coming from universities, research institutions, industries, and companies spread across 5 European countries. We started working on 4 main pillars, and we will be engaging on sectors of the food and beverage industry that have high water usage. At this project, there will be 4 demonstrators: an industrial symbiosis demonstrator in Greece, combining brewery, dairy, and food processing industries; a tomato processing demonstrator in Italy, a meat processing demonstrator in Spain, and a fish processing demonstrator in Iceland. For achieving the desirable circularity, the demonstrators' targets include water and energy saving, reducing the environmental footprint, reducing the amount of resources wasted, reuse of water, energy, and byproducts, and production of new ingredients that could bring additional economic benefits to the participating companies. The Axel Water project will assist the food and beverage industry to deliver safe, high-quality products while minimizing the impact on natural resources, mitigating climate change, and developing alternate value streams. We are a community that visualizes the change of habits in the food and beverage industry. We are working on closing the loops and establishing strong symbiotic relations by implementing innovative, viable, and circular solutions. Join us during this fascinating process.
So that was a small video we produced in order to introduce our project to the masses. That's all from me. Of course, like I said, we're almost in the middle of the project, so since we'll be having results from now on, if you're interested in the project, feel free to subscribe to our social media channels, or check in with our website and the newsletter that we have every 3 months. Thank you for your attention. Thank you, Simos, for the invitation. And if there are any questions, I'm happy to answer. Thank you.
Thank you, Vasily. We move on to the next project presentation. Will be given by George Tsimiklis. He's a researcher within the iSense group of ICCS. Yorgo, the floor is yours. Thank you.
You should be having. Yeah, till the presentation is on, at first I would like to thank everyone for being here. It's a pleasure to be among so many people that we were collaborating the last month. I was very happy to see all the presentations before, as we also participate in a series of projects that were previously presented. And it's also very nice to see how all part of the solutions that were previously presented are further elaborated and are also part of Cardimet project. Cardimet project has not started yet. If I'm not mistaken, even the grant agreement is not signed. We are in the process of signing it in the next months. And I'm very happy that I will be among the first presenters of the project. Not sure, Seamus, if you have already presented it somewhere before, so yeah, very happy to be the first presentation. So I will mostly talk about the vision and what we want to achieve rather than the results. But already we have a very good view of challenges and research gaps we have identified in a series of previous projects. And at the same time, we would like also to bring together a series of solutions and innovation pillars that could bring us to the next level of climate resilience. The project is quite big. It's a total of 51 partners, and they are spanned around the Mediterranean biogeographical region. It's a part of the projects that were funded for the mission for climate resilience, so it was last September. We are planning to start on the 1st of September, but as you can understand, like a consortium of 50 plus partners, it was quite challenging to bring together and also sign the contract, but we are close to that. And as I said, we are focusing on the Mediterranean biogeographical region, so we are covering almost all the countries of the Mediterranean and the majority of the neighboring countries, where we will try to showcase our solutions. The project overall is formulated around 4 main pillars, and also the objectives that we have set are around them. So I will not say much about the objectives, so I will try mostly to show the vision through the innovation that we have put in place. But in brief, we will deliver a comprehensive digital framework. We are trying to work with holistic modeling tools, starting from the local scale, going to the regional, and also from cross-regional types of modeling. How we can scale up resilience and be part of a community service. And of course, all these are based of a big list of nature-based solutions, so we'll try to see how they can be applied at various scales. And last but not least, we want, of course, to create a network and establish a growing community around NBS. We have seen very good examples of communities around water. So, we will try to further expand the community towards NBS. So we already have part of the community being part of ongoing initiatives of NBS. But we would be happy to see also how we can share the results through an alliance that we will build, but also with all the other initiatives around Europe. Yeah, that being said, the concept and all our original discussions, trying to fit, of course, a 20 million project and try to be as abstract as possible in our approach. We decided to focus much on the technology and more specifically on digital technologies, as they could be a key part of how we understand the impact of NBS and how we can better monitor all of them. And what is a very important aspect that we have seen, and we even had the difficulties in the first stages of our development, was the modeling part of NBS, and more specifically how we can go off the local scale that most of them are applied towards the regional scale and the regional application, as we wanted to be part of the mission of the climate resilient cities and regions. And indeed, it's one of the areas that is still missing. It's under research, so we're very happy to be based among indicators that are already identified for NBS, but mostly focus on the upscaling at this stage. Of course, a part of it comes with socioeconomic resilience, which are fully coupled with the application of these solutions and the capacity building for the cities and regions in order to apply all these solutions. And finally, building upon also what was previously presented as part for the DRUSA project, we would like to see also the Nexus approach for water, energy, food, and ecosystems as another way and another approach for impact assessment. And that could be also used for the replication part of our activities. And finally, we have a big list of nature-based solutions, which, as you can understand, like from the size of the projects, like I think there are more than 90 solutions overall applied, which we have tried somehow to group them and see also the impact of how a bunch of solutions can be applied, or how this could be coupled, or like how could be transferred in various contexts within the Mediterranean biogeographical region, but also beyond. This is like, let's say, like a kind of the whole project overview. We are starting, as said, like with the application of our solutions in 9 demo cases and more than 20 communities, where we will try to collect a series of data coming also from on-site collection, where we will install like in situ sensing devices. We will be monitoring the interventions also with remote sensing techniques, starting even with drones, but also with satellite data. We will have a fusion layer where we will try to make value out of the majority of this data that we collect. And finally, we will go towards an NBS intervention management platform and layer, where we will try to correlate all the collected data and try to take better decisions through also like other aspects and pillars mentioned before, like as social aspects and the local context for the application. And of course, we are targeting communities, regions, research, and all the governance for the local communities. And another aspect that we thought that was quite important was also the local industry and the industrial ecosystem in each of its cities and areas. Like we have seen even from Christos before and Ultimate, the context of industrial symbiosis, where it's very much expanded the last years towards the concept of industrial urban symbiosis, and how the local industry can play a key role towards the resilience of the local communities. So even if it was not the main part of the topic, we believe that it's still an aspect that we need to consider and keep in mind, like in all of such projects, and also like how we design and develop such solutions, as the coexistence of both can play a pivotal role for the resilience level that we want to achieve. And last but not least, as said, like we will have a series of regional resilience actors, like trying to perform a total impact assessment, but also a resilience alliance, which we will initiate as part of the project with all the regions and the participating entities in the project. But we also have community groups and working groups that are ready to uptake the alliance later on, like the Clay Alliance that is also part and is leading this initiative in the project. I have to admit that I don't remember by heart all the sites that we will interfere, but here you can see an overview of it. Like our main concept was, of course, like to cover all the areas of Mediterranean in order to be sure that we apply our solutions in a wide scale, but also engage the local communities and have a full coverage of the Mediterranean region. Part of the projects, part of the sites, are already parts of ongoing initiatives and projects. Many of them are also part of Water Europe and part of the projects that we have seen before. Some examples, like even if Simos didn't talk much about the DRUSA demonstrators, but we continue the work that was done there. Like we are working a lot, like with other communities with a different level or different needs. In order to choose also our demonstrators, we have chosen like communities that are having different levels. For example, we have already participating communities that are part of the 100 cities and regions for climate resilience, whereas we have some others that are in the process of being in that and are willing to become members throughout the projects. So we also believe that the mix of local but geographical, political and social solutions will also help the cities to improve one from the other towards the next parts of the project. Here it's a mix of all the NBS that we will apply. Apologies if it's not much seen, but in any case, I will not enter in details about the type of interventions that we will do in each of the sites. But the most important part and what would be a key outcome, at least from our initial approach, was to try and bundle the NBS into NBS units, or like types of solutions that are contributing towards the same results, or potentially could have the same results for the local community. So that being said, like we will work with rainwater management, with vertical greening systems and green roofs, for technologies for treatment and recovery. Also with soil, but also with water bioengineering, and also towards material recovery, but also with soil quality aspects. With public green spaces for the cities that will interfere. And last but not least, also about food, as we have seen also from Vasilis, it's a very important part of and especially even with solutions about urban farming, but also with peri-urban areas, and of course, like the adaptation versus mitigation actions that the regions and the cities are taking in order to design the holistic food production system. In order to achieve, like again, like a wide span of solutions, like an important factor is the type of areas that we apply the solutions. So we have tried to have a full span of natural zones and rural zones, suburban and urban centers, core urban centers, but also the industrial sector. Of course, we don't have the possibility to apply all the solutions in all the type of areas, but at least we will have the first data and first results, which could be used for our impact assessments and could act like as a base and a knowledge base for our modeling tools towards this holistic approach of design for the cities and regions. Again, like another factor that we considered for the application of NBS and how this could be upscaled and reach the TRL 9 by 2030, which is also the vision of Cardimet, is the coexistence already within the projects of the NBS designers, all the technologies that enable the application and operation of the NBS, the adapter cities, and also have the capacity and the access to all the infrastructure needed in order to install the NBS. But finally, also we have part of the project, all the NBS developers, which indeed, like, it's not something common in most European projects, but on the other hand, we had the possibility to design a very big project and make it exactly as we wanted, which of course give us this possibility to reach like the outcomes and also like go in a direction of coexistence of all the critical actors that could reach us to the final implementation of our solutions. That's all for me. It's a great pleasure, and any questions, I suppose, will be later on answered. So thank you very much.
Holistic projects. Yes, of course. Yes. Holistic, also from the point of view of the number of partners. Yes. Well, I mean, we have to say that these projects are really complex, also because, I mean, to address the water challenge, we really need to have, I mean, a systemic view. It's not just the helicopter view, I mean, it's a systemic approach view. Now we have the last project that will be presented, but before introducing the last project, I'd like also to highlight, I mean, a detail which is about the last project and the Axel Water. Both projects belongs to an initiative called SPIRE, which is the Sustainable Process Industry through Resource and Energy Efficiency. This is a PPP, so it's a public-private partnership that was managed by the Association SPIRE. Now it is under the name, under Horizon Europe, of Process for Planet. And this PPP gathers 10 industrial sectors, including water, and Water Europe is one of the founding members of SPIRE, and of course of Process for Planet, which is basically oriented on providing support through the instruments of the Research and Innovation Program before Horizon 2020, now Horizon Europe, particularly in the cluster 4 of the pillar 2 of Horizon Europe, in which water, energy, resources represent from the industrial sector, I mean, a challenge to be addressed as well, but once again, I mean, in a systemic and holistic approach. So let's call, I mean, the last project now, which is, as I said, one of the projects belonging to the SPIRE initiative, or the SPIRE PPP. And I'm really honored to call George Arampakis for Aquaspice, which is another project that Water Europe is pleased to be a member.
Thank you, Andrea. Thank you. Hello from me. I'm George Arampakis. I'm associate professor in the Technical University of Crete. And I'm going to present Aquaspice project, as Andrea said. I know that it's a bit late. I'll try to be as short as possible, but okay, I have to present something. Let's start from some general information related to this project, the Aquaspice project. This project gets funded under the SPIRE, under the topic you see, under the SPIRE PPP. I wanted to also have the plan to say something about the SPIRE, something about Process for Planet, but Andrea said everything about this. That also means that my presentation should be a bit shorter due to that. It's a SPIRE project. That means we're having all the demonstration, all the technologies around process industries. This is the main part. Everything is about process industries, but dedicated to the water. So Aquaspice, as you see, it's a medium to large project involving 27 partners in 11 countries, 5 case studies. We'll talk about that, and it's a 4-year project. Probably get an extension to that. These are the objectives, usual objectives, as probably the most of the projects that are presented today. It's the reduction of water use of fresh water and the reduction of the use of fresh water in the process industry. That's important. It's the steps towards near zero discharge using closed loops. It's a very typical, very close to our innovations, the circularity. I'll elaborate on that later on. It's the recovery of energy and substances. It's something that was central in the call, and increase of water resources. So I'm going through that very quickly because I'll discuss about that later on. I'm sorry about this. And this is something important because in Aquaspice we elaborate on 3 different innovation pillars. Central in that pillar is the circularity, the circular innovation. I'm again elaborate on that and on the different water loops, on the water cycles in the different levels that we targeted in this project. Also, the other pillar is the process innovation. And under this project, some state-of-the-art water treatment technologies and closed loops practices are demonstrated, are tried, and in the use cases that we have. But it's very important that this project has a very strong, let's say, character on digital innovation. There are some strong ICT partners in our consortium that have a strong experience on the area of Industry 5, Industry 4, that we're going to bring this experience into this project, into the water domain, and probably into the industrial water domain. So under this project, we develop a real-time monitoring system, a virtualization of the systems in terms of digital twinning, in terms, and building at the end a cyber-physical system. This is something that I'm going to explain in more details later on. This is a consortium, there are 26 partners involving research institutions, universities, etc., strong research institutions, companies, SMEs, and large companies, and also some very big industrial partners. Also, we have, as I mentioned before, 5 industrial case studies and 7 use cases, if you like, sub-cases. I'm going to discuss them, I'm going to present them after that in more details. And let's go to the case studies. Let's go to the use cases. The first one is, let's say, focuses mainly on the technologies, on the water treatment technologies for freshwater intake reduction. And behind that is a big industrial partner, Dow Chemicals, with 2 industrial sites. These are the 2 different sub-cases or use cases, if you like. One in Netherlands, in Terneuzen, and the other one in Germany, Bellen site, where the main focus is, as I said before, on the technologies of reducing freshwater intake. So in the first case, we tried many technologies in order to reuse water from cooling towers, from blow down of cooling towers, or condensate from the side condensates. More or less the same with the second one, but we also treat and to use different water sources there. The second one, here. The second one is, again, a very interesting case study in Italy, and the main industrial partner behind that is Solvay, also a big chemical industry. But together we have Aretusa consortium, which is a PPP, public-private participation water reclamation plan involving some industrial partners and the local community. It's a very interesting case because apart from targeting on a very innovative or state-of-the-art water treatment train for treating the water from the peroxide production unit of Solvay, we also examine in this case the collaborations with the local community and this Aretusa consortium. So we have, should I say, a systemic case study here in terms of circular systemic solutions that is central now in the European agenda. I don't know if Francesco is here. It's behind this case study. So if you have some time, I can invite Francesco and talk about this case study for the next 2 hours, but I'm sure that you don't want to do that. In any case, let's go to the next one, which also has 2 sub-cases. It is located in Flanders, in the port of Antwerp, and there are 2 sub-cases. One behind that is Waterlink. Waterlink is the local water company that provides water to all the users around the Antwerp port and the canals that are there. And this sub-case, the main concept behind that is to install a series of sensors in order to provide information about the different places in the canal. The sensors are mainly measures conductivity, depth, and temperature. And the second one is, again, an industrial with a big, again, chemical industry, BASF, and the whole case is targeted in, first of all, the optimization of the cooling towers and the water reuse from the different streams from the crackers that they have in this chemical industry. The fourth case study is in Romania, and it's about a meat industry, a big meat industry. In this case study, we also examine some collaboration with other industries in terms of industrial symbiosis that Christos presented very extensively before. And also in this case study, because it's located in Romania, one focus is to provide, let's say, the culture of water reuse, both in industrial domain and in the urban domain, I mean, everywhere. And the final one, case study 4, is about an oil refinery, a big oil refinery in Turkey, Tupras. It's the biggest refinery. In fact, it's the biggest company in Turkey. So we're happy to have also this case study on board and examining different water reuse loops inside this factory. And discussing about the circularity, the circular innovation pillar that I said before I'm going to elaborate, it's very important that in this project we examine different levels of loops around an industry. Having the industry as a hub for circularity, for example, where we can examine different loops. And all these loops are in our case study, starting from first level where we have loops, water reuse into the same process. For example, when we reuse the blow down water in the cooling tower to replace fresh water. We also, the second level, we examine loops, intra-factory loops, where water can be used inside the factory in the same production line, on a different production line, but inside the same factory. We have the third loop, kind of loop that Christos presented a lot in terms of ultimate project, in terms of industrial symbiosis in water domain, between the interests that are in the same plane, but also have the fourth loop that's above that. It's something that it's central to the European Commission against strategy, the symbiosis of the water, of the industry with other sectors, agriculture, domestic sectors, etc. We have this interesting case in Italy where we have collaborations with the local community, so we go into this exactly term that we said, industrial urban symbiosis. Again, around industry and in the water domain. This is innovation, this is the main innovation pillar of circularity in Aquaspice project. And the second, I'm going to elaborate and present a couple of slides and stop and finish my presentation is about digital innovation. And as I said before, digitalization is central to Aquaspice. We are happy to have strong ICT partners there, coming from the Industry 4, Industry 5 domain, and we want to apply there, and to create something that I'm going to present later on that we call water cyber physical system. It's a cyber physical system. I'll show you the main parts of this and understand it, taking into account that this cyber physical system and will, let's say, complement all the closed loop practices, all the process innovation, the state-of-the-art technology that we have, we complement in order to advance the water efficiency and enhance the water efficiency of these technology. So this is more or less the architecture of this water cyber physical system, but it's not so difficult to explain because on the top we have what we call the physical system. The physical system is the industry with the production lines, etc. Also the ecosystem around this industry involving other industries, other sectors, etc. And we have the water saving and reuse technologies that we apply as a process innovation in Aquaspice, also the external reuse. In all these in physical system, we deploy a lot of sensors measuring many different parameters that are of interest. And in the mid, there is, we call it as a real-time monitoring platform, a platform that in fact collects all the information from the sensors, harmonizes it, cleans, do some edge analytics if where is required, and provides all this information to the main platform, to the digital platform, to the cyber platform that is at the bottom with the green color. And this, let's say, digital platform, more or less, the first one that does is to visualize the whole system in terms of interconnected network of digital twins of each asset, etc., and provides a lot of intelligent services. What kind of intelligent services? You can have an idea on that. Intelligent services, for example, data analytics, prescriptive or descriptive analytics, or predictive prediction of the future that can be used in predictive maintenance, for example, or as part of the simulation of the system that can be provided. Also, anomaly detection, root cause analysis, all these services, intelligent services that are usually in an Industry 4 domain. We also have a rather innovative dynamic of life cycle assessment. It's something different from the ordinary life cycle assessment in terms of it gets information, the real-time information from the real-time monitoring system, and provides LCA indices in real time in life. So it transforms the LCA from, let's say, strategic tool, where different scenarios can be assessed, into an operational tool. And we also have a symbiosis-enabled platform similar to what Christos presented before. And I'm finishing my presentation with this one. We are now at about 30 or 32 months. The main focus during this period was on the process innovation to deploy the system in the industries, the water treatment systems to make them work, but we're also starting developing the water sub-physical system and some of its services. And we also have now a prototype that has been applied in Dow Belen, and you can see some screenshots from there. It's the main screen where is a process model there with the different information, the alert monitor log, well, different alerts that happens now, what should be happening in terms of anomaly detection, and also screenshots from the live LCA, where you see the different curves. There are LCA parameters that we capture them, we follow them through time. Thank you very much. Thank you very much, Andrea. Thank you very much.
Thanks a lot, Yorgos. And I'm also following a little bit the project since I'm a member of the advisory board. And It's a very nice project also. So we are finishing this part of the project session. We are going to wrap up and have some discussion at the end of the session. So we are moving on to the perspective of the water utilities. And we have the pleasure to have here with us Mr. Stathis Faridis. He's an environmental scientist and the director of the Major Works Division. Oh. Okay, you can say it properly then. I always get confused with the different divisions of EIDAP. There's so many, and they change so often that it's difficult.
Very high upgrade now. So
Okay.
Actually, I wanted to thank you for the invitation from EIDAP. And I wanted to convey the greetings, hot greetings and wishes for my General Executive Director of Major Works, Georgia Stefanakou, and my Director, Evangelos Fougias, which are having, they are very busy at the time. As I in an email for the first email we connected, I said that we are a very great team working in the projects, classical projects, you know, infrastructure projects for wastewater in the East Attica region. So we would like, we wanted to share with you, take this opportunity and share with you what we are doing, how we take this, let's say, delayed infrastructure construction state in Attica, and making it an opportunity to embed circularity, and we use reuse projects and projects of circular economy. So, I don't know how many of you are familiar. Okay. So, many of you don't need that welcome. I wanted to welcome you to Attica because no, you have to realize that it's the place where the EIDAP is working, and you know, where the majority of the population really resides in the Athens Basin, where you can see. I don't know if there's, and Athens Basin is actually the main part that has all the infrastructure. So Attica is also a water-stressed region, considering mainly agriculture, something you wouldn't feel in a rainy day like this, and yesterday in Athens in June. To introduce you to our company, just a few numbers, which I know that the researchers have scrutinized and really know a lot more about our water cycle, about our water numbers. But this is also an introduction to our company. You know, EIDAP is the largest company in Greece. It's a water supply, storage, and wastewater treatment sector. It covers the needs for more than the 40% of the population of the country, and supplies Attica with high-quality drinking water. Our main numbers: 1 million cubic meters per day water supply, 700,000 wastewater, 1,000 cubic meters of wastewater a day, treated to 95% and disposed to the sea. For water supply, for the quality of the water, we got 10, excellent. It's well known, you can taste it yourself in the taps. We need a lot of work for water circularity grades to go up. So let's see the situation. Let's see here the Athens Basin. Greater Athens. We see in our cycle, you see the sinks, we see the wastewater treatment plants. Sitalia wastewater treatment plant, it's our beloved plant island. It's had a long way. It's one of the biggest wastewater treatment plants in Europe. Then our newest Thriasio wastewater treatment plant, and then Metamorphosis, which is the oldest treatment plant, maybe even in Greece, which was constructed even before the network was there. So now, you see this arrow there, this wastewater treatment plant is used to take the wastewater from trucks that empty septic tanks from the settlements in the rest of Attica that still doesn't have wastewater infrastructure. So this is a situation that lasted a lot of years. Let's go to what happens now. This is a quick view of our projects. You see the vastness of the area that our projects will have to cover in a very limited time. You see kilometers of pipes. You see also the distance from the Metamorphosis wastewater treatment plant from all the rest of the Attica, where still now wastewater trucks, tank trucks, go there with emptying all the septic tanks from all the settlements. And there are big settlements in East Attica. So, 3 major wastewater plants. I will just show you some numbers about their ability to reuse and irrigate, because after a new master plan was prepared for East Attica, for the wastewater treatment, there was an opportunity there. It was in 2016, so there was an opportunity to upgrade our way to deal with wastewater. So all the plants now are designed for reuse, are designed to produce water that is safe to irrigate, unrestricted irrigation. So we are still in the construction phase, but this is the plan right now. So in Marathon, we will be able to irrigate 410 hectares of agricultural land with a future expansion to more 250 hectares. In Rafina, Artemida, the plant there, as you see, is designed with MBR technology. So it's actually designed for unrestricted irrigation and urban suburban use. 840 hectares there. And another wastewater treatment plant, which is actually now in the trial phase. It's constructed. Its construction is finished. It's in the trial phase, and in the future is scheduled to take also the part of the Saronikos coastal area settlements and irrigate 1,200 hectares of agricultural mainly land, and there's also an opportunity there to proceed to aquifer recharge. There has been a lot of studying for that, and it will be able to take 65% of the produced water from the treatment plant in the winter months. That also closes another loop, because the aquifer there is considered polluted. It's characterized as bad in the river basin management plan. So this is another way to add something. And Also, we will deal with saltwater intrusion in these coastal aquifers. I don't want to speak more about all the projects. Let's see this one. Maybe there you can see it's a Rafina wastewater treatment plant. This is the site of the plant, and around you can see the settlements that will be served. Firstly, see how sparse the settlements are. I was very interested to see all your presentations for your pilot plans and innovations and decentralized plans. So if you look at it your way and you saw that, maybe you say, why not put some small compact plants and not build all these pipelines? We have 430 kilometers sewer network. Anyway, there's a different approach from the classical approach of infrastructure. And it is very useful to have this connection with all your research and implementations. Just to show you that the plant itself is in a place with a lot of, it's an agricultural landscape actually. And the numbers to show the plant irrigated land, you see there's also safeguard that this 840 hectares belong to a zone which is a flight safety zone for the airport. It's only cultivations and agriculture that is permitted, so we can be sure that there are places to irrigate. So our approach to implement these projects, their use part and the irrigation part of this project is chosen to be a very systematic, step by step, and very careful one. We have to do all the steps, take all the permits, make the studies. We have a master plan for reuse from 2017, which can be updated when needed. We have environmental impact assessment studies for all the wastewater treatment plants. Sometimes we needed appropriate assessments for some projects that are near Natura sites. We have our climatic proofing. We have irrigation studies, special irrigation studies for the places that we plan for aquifer recharge. There were special hydrological studies made and numerical modeling, and will continue. And we have a marine monitoring program with National Center of Marine Research, collecting baseline data to monitor the condition and the impacts in the coastal environment. A significant step to the implementation is a feasibility study for all the reuse master plan, which I saw from your presentations that you also have done in a lot of your projects, and we will be very interested also to exchange data and experience that. We have to check our market, we have to check our use customers, we have to answer questions like who will pay for aquifer recharge, which it will cost for the treatment and the studies and the monitoring, who will pay for urban suburban reuse, and will the farmers pay? You know, the vision is that the farmers know better, they expect this water. They want this water because they know that it can be in a consistent quality. Also, cost-benefit analysis for water reuse, infrastructure. We need to check water pricing, tariff policy, and being in a very fluid legislative environment, which now we have a new regulative authority. We have new legislations, new EU legislation. All these have to be constantly updated and checked. So people's acceptance is key to our projects. So our water use projects include a Center for Environmental Awareness and Information. It's actually adjacent to the waste treatment plant, as you can see there. And we planned to have it as a hub for information, to exchange ideas, to educate people. So maybe in the future, a workshop like this could be in this, this center when we actually finish it. Some numbers quickly. 400,000 residents are to be connected to our new sewer network. It's going to be 1,300 kilometers of sewer network. Our wastewater treatment plants will have a capacity of 48,000 cubic meters a day. I just want you to remember the numbers of the basin, the Greater Athens area, the core EDAP. And in water use, we plan to have annual reclaimed water, 800, nearly 9 million cubic meters after the construction phase, which will go up to 14. This gives, if we do the math, it gives around 50% reuse. So in our initial irrigation phase, we can irrigate 1,600 hectares of agricultural land, and will be up by 2040. We will also be able to do aquifer recharge, as I told you earlier. And considering other parameters in circularity, our projects also embed new technologies, have high-level automation and modern SCADA systems, and energy recovery. We have utilization of biogas. It's usual stuff that it's embedded in the planning of waste treatment plant. So we have even a small hydropower project for the outlet in Marathon. And considering solid waste, the sludge is going to be digested and dewatered. It's not too much. The sludge, the first phase is planned to be carried to the Psyttalia thermal drying unit and then sent to cement factories with the rest of the sludge of ADAP's wastewater treatment plants. But considering the landscape, I show you that this wastewater plants are, and the fact that they will serve mainly in urban areas, it's also an opportunity to promote agricultural use of sludge, and we are having it as in plan. Lastly, our view as a service provider, as a water utility, can be nothing more that the road ahead is towards water circularity. We need to embed it in our everyday solution. I was really very happy to see all of your projects steps ahead in reality of our classical view. And we are really, we will really be happy to have more connection. I know you're connected with our R&D department, but I think it's time to, infuse into the constructions and the design for our works. So finally, a holistic approach is required. You need collaboration. Now, we said collaboration between researchers and engineers, but we also need collaboration with local authorities, farmers, other user groups, and you need environmental awareness. And being in this job for some years, I feel that it's good to be optimistic, but we need careful steps. The potential positive feedbacks, if all goes well. We will have water conservation, environmental protection, and long-term security for the region, for East Attica. but it needs a lot of work. So this was a view for our new projects that were designed, and the circularity, as much as we can say, was embedded in the design phase. Now, I would like to call Dr. Katerini Dimitrou to present you a case of implementing projects in our existing infrastructure.
Thank you, Stathis. And I would like to take this opportunity to thank you very much for the opportunity that you give us in order to present the point of view for a already known project, sewer mining, and the point of view from ADAP, not from the technical part, but from the commercial part, where we are trying to incorporate in our business this innovative technology. So I'm not going to cover any technical parts because they are already familiar, I think, to you. But as I told you, we are aiming in making sewer mining a new business activity for ADAP. And we are developing a 5-year project that involves the installation of 27 sewer mining units in 20 parks all over Attica. That will produce annually 470,000 cubic meters of non-potable water for direct local irrigation needs. The estimated budget for this project will be around 5.5 million. And of course, for ADAP, that will be with no economical profit. Since it is a main axis in ADAP's sustainable development strategy for a circular economy that contributes to climate change mitigation, reliance to the urban heat effect phenomenon, and enrichment of the aquifer horizon. Our partners in this project are the National Technical University of Athens, Chemitech, and the Municipality of Athens and Markopoulou. As I already told you, we are involved in the sewer mining since 2015, possible, before the first unit was installed in the ADAP's R&D Center in Metamorphosis. And there is a new, thank you. There is a future unit that is will be installed in Markopoulos within the end of this year. All this experience and the expertise that we have gathered from our R&D department, we are trying now to implement an actual and make, and from an R&D project move to a real-world situation and develop a business plan that we are already working on it, and trying to incorporate this project in ADAP's master plan for wastewater. What is the major challenge in this project is the high price of the reused water, comparing to the low price of potable water that EIDAP actually provides for irrigation needs. So we are actually competing with ourselves, and this is a problem that we have to overcome. We are planning to reduce the cost. We're taking some important steps and working hard to be under of 2 euros per cubic meter. Another challenge and concern we have is the sludge return to the system of to the waterway system of EIDAP, which is prohibitive. So we have to make amendments in our internal regulation in order to stop this problem and allow the sludge return in the network. A major challenge for us also is the high cost function of the unit in terms of energy and operation. In the next project in Pentus that we are planning to install in Markopoulo. We are trying to address these problems, trying to use as much as possible renewable energy from photovoltaic panels. And of course, we are want to see the new innovation of digital twins that will reduce the physical presence and allow remote operation. We like to see that working and draw our conclusions out of it. Another concern is the size of the unit, and of course the aesthetic of it, because to be honest, I don't think there is nothing wrong with the size. The problem is the size of the parks that we plan to install these units. In Greece, the parks are rather small, and so that is the main problem, that you have a small park compared to the European and other continent parks, that they are really huge. And so in order to have it apparent, it has to be of some modern aesthetic, and we are addressing also this concern. Theft and vandalism is also in our agenda, and we are thinking to have security measures through cameras and possibly green fences around the unit. We expect and anticipate some local public reaction, because there always is in these cases, but we want to raise public awareness through educational campaigns, and to actually combine that with all the infrastructure that is being built in the East Attica. And last but not least, I would like to emphasize the lack of incentives. It is very important for us to have strong initiatives for the implementation of substantial financial and social incentives from EU that will also push for changes in the national legislation framework, because incentive for us is the most important factor that it is required to be addressed at this point. So I will close my presentation by just showing you a timetable of our next 5-year steps that will try to get the sewer mining from our R&D department to the real world and make it a business for new activities for ADA. Thank you.
We'll take questions later, please, or all together. I'm glad to see these important infrastructure works that are being part of transforming Greece. At the moment, regarding water reuse, the country is very low, it's around 2% in terms of direct water reuse. To give some examples, Israel is above 75%, maybe above 80%. Cyprus is close to 70–75%. And I think this will change quite a bit the map in terms of water reuse because there are big infrastructure works. So thank you very much, both of you, for your intervention. Is there any other intervention from water utilities part? So, yeah. So we have with you the Association of the Greek Water Utilities with us.
My name is Christina Kutsifaki. I'm a chemical engineer and a member of the Environmental Committee. I come from the water utility of Chania. Πώς πάει? There are now 126 municipal water companies in Greece, serving approximately 5,200,000 people, with a yearly turnover of 500 million and distributing 400 million cubic meters per day. The working environment for us comprises the emerging pollutants, climate change, circular economy, energy cost, resilience and operational efficiency, digital transformation, whereas we have to deal with threats like the recent pandemic and extreme weather conditions, wars, etc. We all know the circular economy principles: design out waste and pollution, keep products and materials in use, regenerate natural systems. And the water in circular economy is recognized as a finite resource which preserves the natural capital of water. The dimensions of water applied in circular economy principle is as a carrier of nutrients, chemicals, and minerals, a source of energy, kinetic, thermal, biothermal, hydroelectric, and a service through drinking, sanitation, cooling and heating, and part of the production processes. So, in the water sector, we design out waste and pollution by reducing waste, eliminate the use of toxic substances that impair reuse, optimize energy, minerals, and chemicals use, use renewable energy, optimize the consumptive use of water within sub-basin, and use measures and solutions to deliver the same outcome with less or without water. Optimize yields within the water system in energy, chemicals, and water. Optimize energy and resources extraction from water systems, and unlock add value from resources. So in these ways, we keep products and materials in use. And of course, regenerate natural systems, maximize environmental flows, preserve preserve and enhance the natural capital, ensure minimum disruption to natural water systems, and incorporate nature into mainstream infrastructure system. The EU plan for circular economy that consists of carbon neutrality, sustainable environment, and toxic-free environment lead in reduced water scarcity problem, resilient services, reduced greenhouse gas emissions, energy, and makes the water systems more sustainable. With less, we have less biodiversity loss and limited landscape disruption. So the legal framework within we work, all the water companies, is in a time of change. And these changes are in line with circular economy principles. In quality, we have more strict quality standards for water and treated wastewater. We have to deal with emerging pollutants. The risk-based approach is introduced in every aspect of water and wastewater management. And there is, the pollution should be, all the policy is towards tracking the pollution at source and avoid end-of-pipe solutions. In line with this, we have efficiency and governance things to do that have to do with leakage assessment and reduction, transparency and accountability in the operation and use of resources, operational resilience, and cost recovery. And in the reduce, recover, recycle phase of circular economy, we have to deal with energy neutrality, energy audits, and greenhouse gas monitoring and reduction of emissions, and towards sludge and water and phosphorus reuse that have to be incentivized. So the legal framework, we are truly in a time of big changes. There is the new ministerial decree, the new Greek legislation on the quality of water that came into force a month ago, in April, less than a month ago, in May 2023. We have the directive 91/271 that was the founding directive for the wastewater treatment, is in the last stages of revision by the European Union. The existing directive was focusing on secondary treatment, and the sludge reused, according to Article 14, was to be applied whenever suitable for purpose. That was something very general. We also have the new regulation, the European regulation on the minimum requirements for water reuse that comes into force in 15 days from now. In Greece, we had the ministerial decree of 2011 on minimum requirements, which I think will be replaced by the regulation. The Ministry of Environment is in the process of dealing with that. And in April 2023, we had a new ministerial decree on the use of sewage sludge in agriculture and landscape restoration. We don't have a new European directive on this, which will be effective in the next years. On top of all this, we have the climate law of 2022 that requires yearly energy and greenhouse gas emission audits for wastewater treatment plants over 100,000 people equivalent. We have to reduce the greenhouse gas emissions by 30% up in 7 years from now. The activities the water companies applied for reuse, we move from traditional practices, which is sludge, effluent, reuse, and electricity production from biogas, to new practices that incorporate renewable energy production, mainly from photovoltaic stations, energy upgrades, leakage reduction, which is compulsory according to the new directive for water quality, smart water metering, and nutrient recovery. The sludge reuse up to now had some limitations because of the legislation, because it was very strict on requirements on a user basis. So there had to be permits on a user-by-use basis, which it was not a prerequisite of the directive, of the European directive, and this makes the application rather difficult. This remains unchanged in the new legislation. On the other hand, the quality standards, which were about heavy metals, were easy to conform with in absence of heavy industry. Now, the new reuse decree introduces landscape restoration as a use for sludge, introduces acceptable level of treatment in order to the sludge to be reused, and also introduced micropollutants and microbiological standards. These are on top of the existing EU directive. To achieve this, secondary treatment might not be enough for the wastewater to produce sludge with the appropriate quality characteristics. So we should move, it's a case we should move from end-of-pipe treatment to a control at source to ensure sludge that will be okay for reuse. The European regulation that comes into force in June for water reuse has a very short list of quality standards and is rather flexible in application concerning the type of irrigation, but introduces again risk assessment for every small application of water reuse, and requests to raise the public awareness. The existing regulation was strict in the standards and the level of treatment required, but on the other hand, it has been applied to numerous small wastewater treatment plants that had no solution to send the treated wastewater to the sea. And for big wastewater treatment plants, over 100,000 people equivalent, the existing decree required conform with priority pollutants and heavy metal standards. I don't know what will happen from next year when the regulation, the European regulation comes into force, if this will be in force still. Now, the recast of Directive 91 moves a lot from the existing directive, requiring extended nutrient removal for nitrogen and phosphorus, no matter what the sea outfall is, quaternary treatment for micropollutants, which is compulsory for big wastewater treatment plants, total energy neutrality by 2040. The water companies have to produce by some way the overall energy that they consume in the wastewater network and the wastewater treatment plants. So that is a big challenge. And it also requires GHG emissions audits phosphorus sludge and water reuse, and urban runoff management, which is a big thing. We will see how we deal with this. Of course, now we are in the proposal phase of the recast of the directive, so we don't know what will be the final text, because in Europe there are big negotiations taking place between the member states now. Now, large-scale water reuse in Greece, as we said before, is extremely limited. It's only what I found there is a platform of the Ministry of Environment, which is called Astikalimata, and where everybody can find data about the water treatment plants in Greece that serve more than 2,000 people equivalent. Only 3,300,000 cubic meters are irrigated, mainly in eastern Crete, Heraklion, and some nearby areas, nothing more. Very small scale reuse within the premises of the plants for 25 water companies, but we have to say that in very small plants, at least the environmental permits say about water reuse. We don't really know how much this is applied in reality. Sludge reuse is practiced in agriculture in 8 water companies. The dry sludge applied per year is estimated about 6% of the total production, and it's in mainly central and northern Greece. There is another type of reuse, which is usually co-composting with other wastes in industrial units, and we have 16 treatment plants in central and northern Greece. Again, about 14% of the total production practicing this. In any case, the huge percentage of sludge reuse is in Psyttalia, which represents the 41% of around 41% of total production. So, and the reuse is the incineration in cement factories. We also have production of electric energy from biogas. Again, the data lead to the huge percentage of this energy is produced in Psyttalia, about 90%. A very small amount of the total energy produced is going to the grid. It's self-consumption in all cases. Now, we have some funding programs that incorporate aspects of circular economy. We have now under development 12 projects through Tritsis and Philodimos projects of the Ministry of Interior, and 9 projects from the Resilience and Recovery Fund of the Ministry of Environment for water reuse. And with the level treatment in all these cases is usually MBR. I have to say that in order for the projects of RRF to be suitable for funding, there has to be a 10% energy reduction in upgrades of plants or net zero in extensions. So the company should produce energy in order to have this funding. There are also 66 projects for renewable energy productions, which is almost totally by photovoltaic panels, and energy efficiency measures. The estimated energy saving through productions and energy efficiency measures is estimated, because the projects, they have not been in place yet, 41,000 megawatt hours per year. And now we also have 19 projects through the RRF program of the Ministry of Environment for sludge drying that will make reuse more easy to apply, which estimate that 23,000 tons of dry sludge will be treated. Closing, I would like to say that circular economy requires a new way of thinking and doing things, resilience and inclusiveness in operation, cross-section linkages, no one can do it by himself, changes in other sectors, household, agriculture, energy, and industry, and institutional framework in place for water companies. We have to plan, get prepared, and attract funding, because all this required substantial funding. We have to educate the public, and last but not least, apply a systematic and transformative approach to delivering water supply and sanitation. Thank you.
Before I give the floor to Andrea for the last sessions, I would like to thank Water Utilities for their perspective. And the last two slides, you summarized very nicely, you know, the takeaway message. I sincerely apologize for the heat. The air conditioning is not working. They're trying to fix, but that's why we opened the doors, okay?
Well, I mean, yes, I mean, if there are any question, I mean, that will be fine, because I myself have a question for you, which is the matter that, I mean, I really appreciated, I mean, I appreciate all the presentation. In the last two slides, I mean, there were, important points. Now, I mean, let's say that there's a kind of password, which is circularity. So we all work, I mean, towards circularity. The problem that I see is that at the end of the day, I mean, in the last 2 centuries, we've been working in a linear approach. All our infrastructure are linear infrastructure. Our design has been always linear. And then, of course, I think that now there is a great opportunity for changing, for this paradigmatic shift, I mean, from the linear to the circular, not only approach, I mean, implementation. Now, my question is, from your perspective, what is the most important or the worst barrier for the transformation, for the transition from the linear to a circular, not approach, a circular implementation of management of the water?
I think most of all it's a matter of approach. I mean, within the water companies and within the in the public. But within the water companies, especially the smaller ones, not like the Athens Water Company, we are kind of used in working every day with the traditional approach. So there is a lot of funding now, European funding, the RRF funding, ESPA funding in Greece. But we have to work with this in mind. In order to apply, really. Not just see there is a funding opportunity, let's do this, and let's do the other thing. In order to apply the holistic approach. So I think it's a matter of approach.
It's a matter of approach.
Yes.
It's a matter of behavior, it's a matter of awareness, it's a matter of capacity development, I mean,
Yes.
of our institutions in order
Yeah.
to have, I mean, a real circular approach for the water, and not only the water and the water sector.
Yeah.
So thank you so much. Thank you. And this is, I mean, also an opportunity to go, I mean, to circularity, and I'm very sorry that we are a lot behind the schedule. So, I mean, I ask, I mean, the next speakers, I mean, to keep that time as much as possible. But going, I mean, from circularity, what we said in terms of having a systemic approach for circularity, now the time comes, I mean, for introducing this now well-known partnership, which is Water for All. Water for All is a co-funded partnership. It means that, and Georgia will better explain, it means that there is an agreement between the European Commission, member states, and other associated countries in working together in doing what? In just, I mean, very simple sentence, securing water for all. But inside this simple sentence, we have, I mean, a planetary thing, lot of things, and a lot of challenges, and of course, I mean, solutions that need to be not just addressed, but really implemented through having the innovation taking really place in our territories. So I'd like to ask kindly Georgia to take the floor and introduce Water for All.
Hello, everybody, and thank you for the invitation to present Water for All. My name is Georgia Nusaki. I come from the General Secretary for Innovation and Research here in Greece, and we are partners in this mega project. Just to give you an idea, we're currently 82 partners, and soon to be 92 partners, involving mostly research funding agencies, national or regional, but also research organizations, policymakers, and economic sectors all relevant to the water field. The partnership goes beyond Europe. We have partners from South Africa and South America, Norway, Turkey, UK, and in the next phase we'll be having aboard Georgia and Tunisia. The partnership started in June 2022. We are currently in the middle of the first phase. It will go on until May 2029 with the core activities, and some of them may be running until May 2032. The thinking between this huge partnership was to collect a critical mass of actors, but also to collect a great variety of profiles in order to serve this holistic approach we're looking for. And of course, to gather the funds necessary to support the activities. The main vision is to bring together the problem owners with the solution providers and what Andrea just said, water security for all in the long run. And let's hope it's more achievable than world peace goal, for that matter. Just getting down to specifics, Water for All has developed a strategic research and innovation agenda as a result of interaction with other initiatives in this domain, and also through a process of consultation, both with within the partnership, but with also experts outside. And the result was 7 core themes essential to addressing the water challenges. As you may see here, it's water for circular economy, water for ecosystems and biodiversity, water for the future, sustainable water management, water and health, water infrastructure, and an additional cross-cutting issues about international cooperation and governance. And this is the backbone of Water for All. These themes are the driving force behind all our activities. And general view of what we're doing can be seen across two axes. The first axis is the annual joint transnational calls, Plan to be 6, and the in-kind scientific activities. The activities are organized into 5 pillars. In the first one, we're dealing with the SRIA development and the synergies with other initiatives. In the Pillar B, it's mostly about arranging the joint transnational calls. In Pillar C, we're dealing with strengthening the interface between science, policymaking, and the end users. And this entails setting up knowledge hubs, policy working groups, supporting creation of startups, capacity building, interconnecting research infrastructures and how they can communicate better with the policymakers, and of course, water data management, a very hot topic. There is Pillar D, the demonstration pillar. I won't go into that, you will hear later on. And there is Pillar E, internationalization. Solutions to water challenges must be on a global level. A year has passed since our starting point, and a lot has been done. In Pillar E, the SRIA has been published and will be revised in 2025. There are ongoing synergies with other partnerships like Biodiversa, Sustainable Blue Economy, and EU missions with Oceans Restore and Water JPI. There are also others coming with food system, agroecology, and One Health. In Pillar B, we have completed the evaluation phase for the first call, published in September 22, and we are already designing the call of September 2023. In Pillar C, terms of reference for knowledge hubs are about to be published. There are ongoing surveys for our policy working groups, and already we have concluded a first survey about startup ecosystem across many countries that offered useful results to work with. PhD SIMs are running, mobility SIMs are about to start. There is material for capacity building. Just a couple of days ago, we had the first online workshop about the interconnection of research infrastructures and how they can communicate better with policymakers. And finally, the water data management toolbox is underway. We'll skip the Pillar D and go to E. Water for All has been present to all major international events, most recently at the UN Water Conference, where our partners organized 4 side events. We'll be present in Beijing and Bali, Indonesia. Our strategy for drafting international cooperation agreements is under development, starting with the mapping of what is already in place and running. Regarding international contacts, Water for All is present at the EU-China Water Platform in the talks with India, Cuba, Uzbekistan, and others to follow. Regarding the SDG 6 monitoring, which is very important to us, there will be a special requirement in the next calls for all funded projects to elaborate how they impact this goal. And last, if you want to be part of this effort, these are the ways to do it. If you're a public institution, research organization, public or private network, you can apply to the annual joint transnational calls, provided that your national funding organization contributes budget, or you can join the partnership as a partner to contribute to the scientific in-kind activities. If you're a funding agency, you are very much welcome to join the partnership and contribute to the future joint transnational calls. And you will find more details on our website and social media. Thank you. I think that is quite short. Thank you for the invitation.
Just before Andres' presentation, if everyone agrees, we will share the presentations of today's workshop. So unless someone is objecting, then... Sure, that is fine.
Does it work? Oh, okay. Now, here we are. So, Giorgio, thank you so much for, this great introduction of Water for All, which is a complex partnership. It's really complex. Starting from the point of the number of partners, the kind of the diversity that we have inside, and of course also the duration of the partnership, which is important because if we really want to make changes, of course, action is needed, but also time in order that action can be really deployed. Now, we all know that if we want to start from, who is familiar with research and innovation projects, when I say TRL 4, it means that technology readiness level 4. We are thinking about an innovation, and we start making research. And then we say that research innovation cycle is closed when TRL reached 9, which might take years. But it doesn't mean that these products will be ready for the market. It's not really in the market yet. So we need really to push the innovation to become available to the market and support the market uptake. In the pillar D of Water for All, wants to demonstrate the solution efficiency and open the market to the solution and support the solution to be really undertaken by the users. For this, we have a tool, because as I said almost in the beginning, water is a local challenge, or rather, we need to solve problems at local level, and using the new, it's not really new, tool that is called water-oriented living labs. And I'd like to also to introduce my colleague Gaia Zanzi, who is supporting me in the implementation of the Pillar D in Water for All. So Water Europe, you know, Water Europe is the recognized voice and promoter of water-related research and innovation in Europe, and we have the mission of enhancing, improving the capacity of the water ecosystem in now and in the future. Water Europe in Water for All, why we are there? Because we are a value-based organization, and really we want to achieve what we call a water smart society. Now, Pillar D accelerates the operationalization of innovative solutions. It brings innovative solutions to the field and promotes, fosters the capacity of the local stakeholder to undertake the innovation and make them really be applied for real. The task, the Pillar D is made of a number of tasks. There are 3 tasks and several subtasks, but we can identify 3 main blocks. The first block is working on engaging with the existing water-oriented living labs. A living lab is a real-life environment where the quadruple helix actors are all present. It means academia, citizens, business, and public institution and government, in order to sit around the same table, having a common understanding on how to solve, how to address the challenges and finding a solution, which means also the capacity of addressing the sustainability issues, also concerning for instance, the investment, the money which is needed in order to implement the innovation at the local level. And so we engage with these already existing entities that we identify as water-oriented living labs in order to engage with them and to extract from this scenario the best champions that can lead by example. Then we go to those areas where water-oriented living labs could be possible, and we support the development of new water-oriented living labs in order to foster additionally the capacity of the territories in implementing the innovation. And then, in order to support both these axes, what do we do? In the Pillar D, we engage with the development investment programs. And look, it's not just a matter of funding, it's a matter of investment. So it means that through the task D3, we support both the existing water-oriented living labs and the new ones in achieving also, say, financial sustainability or sustainability in the long run. Well, I mean, I think that we can skip this slide. I mean, just the matter that we are going to have, I mean, tangible results of this task, of this, I mean, of the Pillar D, for which by May 2024, we are going to have the atlas of the water-oriented living lab, the new atlas, because this is an effort that Water Europe already did, I mean, years ago, with, I mean, a less complex modality and process, and the creation of the network of the water-oriented living labs. Both will be deliverables of the Pillar D, in May 2024, and all this will be presented in a public big event in, as I said, I mean, in June. Now, we go, I mean, to some details about the water-oriented living labs. I would like to give the floor to my colleague Gaia, just, I mean, to give you an idea on how this works and how we are making it.
Thank you very much, Andrea. I hope it doesn't... okay, nothing happens with your mic on. Perfect. So thank you very much to keep the attention up for the last minutes of the presentation. So, and I'm gonna start from where Andrea left it. Tangible results, I think we all like it. So, water-oriented living labs, still the name, it's a bit blurred. So let's go into details. Why? Why there's the need for water-oriented living labs? Because there is the need, the European need, for a local, strategic, long-term innovation on the territory. So it's a way to answer this need and to provide a support to implement solutions. So there is a nice definition, which is long and quite difficult. So to go straight to the point, what we need 4 key elements to define a water-oriented living lab. The link with the territory. It has to be bounded. It has to be related to a specific territory because the innovation has to be local. As Andrea said before, we have also to act locally to address water challenges. And there has to be a representative amount of stakeholders from all of the different helix of the quadruple helix. So ideally all of them, but realistically as many as we can, but that represent everybody in the society. Then it has to demonstrate innovation. We don't have to lose the focus that it needs to demonstrate innovation on a territory. It has to insist to a fit and suitable innovation for the territory. Then ideally it lasts long. Can we dream right now? Forever. So we need a wall to be considered a wall, needs a long-term financial strategy, but also a governance strategy, because they go, as you all know, they go along, and one doesn't exist without the other. Okay, now that we have more or less the idea, let's go down to one case, a specific one. Then in the umbrella Water for All, we identified as water-oriented living lab. This is a provocation. Next time, I would love to present a Greek one. So I'm waiting for you to send me all of the cases possible that you believe they are suitable walls. And this one is in Spain. We're going to the Aragon region. It's called ZINA. It's a cluster for the efficient use of water. And why? Let's go straight to the point. Why related to all 4 key points? There's a link to the territory. It insists on the region of Aragon. It's more in details Zaragoza. And it includes the whole quadruple helix. And as you can see, it is expanding, it has ambitions, and it tries to include all of those public, private, university, research centers, and citizens, stakeholders. Then, through projects, not only through projects, but through technical innovation, digital innovation, citizen engagement, they are trying to deploy innovation in the territory. They're also they're participating in different projects through also their members. And they also have a strategy, a long-term strategy. This one is for the 2022-2025. It's going to be updated. And also, I'm gonna make it short. They also already see themselves in 10 years. We asked them, we try to ask them, how do you see yourself? And we identified a wall here because we believe all of those 4 points are actually in place. And yeah, this is in a nutshell. I hope that helped. And then I will pass back the floor to Andrea.
Thank you so much for the example. I do hope that the provocation will be effective. You're waiting for receiving candidates, water and living labs from Greece, of course. And well, I mean, this is just, I mean, a short story of what happened with the water and living lab. We started in 2018 for the first atlas. It was published in 2019 with quite, I mean, let's say, there was, I mean, a good tool to assess water and living lab, but not as much as detailed as we did in 2022. So we prepared rightly for Water for All these 2 assessment tools. You see, I mean, we started with the definition, the practice, and the assessment methods, and then we published, I mean, the second notebook series that was dedicated to how to assess water and evolve a water and living lab. And then we are going towards, I mean, the third publication that will be about the new tools for building and maintaining water and living labs, and by 2024, as already the new atlas of the water and living lab that will follow this long-term program. So this is, I mean, the definition that we saw before about water and living labs. Basically, I mean, we start from the mind that is a real-life demonstration and implementation instruments of innovation. And this is where we want really to insist. This thanks, I mean, to the participation of all the stakeholders that are needed in order to make innovation really be implemented. This is, I mean, it's just, I mean, you will see that this presentation will be shared with the audience, and basically what we look and how we assess, I mean, the water and labs is about these 6 fundamental elements, which is the governance, the service creation, the presence of infrastructures able to provide the capacity for testing the innovation. This place must have methods, I mean, must have tools. The involvement of the users is important, and we must, the water and labs must demonstrate that innovation is really implemented. So these, I mean, are the steps, assessing the maturity of water and labs. And I mean, this is the end. New atlas with the update assessment method. Establishment of the network, and the network will have, I mean, contents, you know, really to lead by example and to be the example for Europe and beyond Europe in how implement innovation in the water and water-related sectors. The creation of the roadmap for new water and living labs, as well in Europe and beyond Europe. And this is, I mean, in the Pillar D. It's a big effort. I mean, we try to concentrate this in few slides and few words, but it is something that we really like, I mean, to make it visible, because it is, in our opinion, important for the next generation, for Europe, for whoever in this planet, to be able to manage water within the planetary boundaries of this essential resource. Thank you so much. Thank you for your attention. Thank you to all the speakers. Thank you to the conference, to Simos, to Idrusa, and to all the other projects that really create this great opportunity. I don't know if you have any question. The floor is open.
Well, as I've told you some time ago, we would also love to join the Water and Living Labs, our site in Lesbos, that's a circular system. Although it's a small scale, it's a population equivalent of 500 people. I think it's a nice example of that we could join. Please.
Just to offer another Greek case, which we've discussed with Andrea in the past, there is the main demonstration site of the NextGen project, which was also discussed in the context of sewer mining by our colleagues from ADAP. So this is where we really demonstrated, and we brought together as we said, academia, the water companies, and the municipality of Athens, local stakeholders. We are maintaining this. So this is what Andrea was talking about when he said, well, NextGen has finished, but not really. One part is the water marketplace, of course. The other is the live demo environment of the sewer mining, and we would like to join. We have a conversation with Cleo and Andrea ongoing, and of course, we will take it further together with the complementary, I think, case that Simos brings in.
Which is an amazing example, I have to say. I mean,
and a beautiful one, I have to say.
It's beautiful, really, yes, absolutely. And please.
No, I just wanted to say, yes, please, you can find my email, I think, anywhere on the presentation. And there's going to be what we require for the assessment is a Word document to be filled and the Excel, the matrix that you just saw in the Excel. And once you complete both, to send us to be evaluated. Thank you.
Yeah, because there is an open call for submission of candidates for water and living labs. That will be up to the end of the year, if I'm not wrong, right? Up to December, up to November 2023. Yeah, before it's better. I mean, the sooner the better. Also because, I mean, let's say the editorial project for the Atlas is pretty complex because we really want, I mean, to showcase the examples, let's say leading examples, in order to support the network taking off in Europe and beyond Europe. This is important because we are really now the opportunity of making a change, but a change forever in water management. And I think that water and engineering labs really represent the way forward to have the change in the real life. And let's say passing from the dreams to the real life. I mean, I think the water and engineering labs could be a good bridge for having this done, I mean, I think in a short time. Also because really we do not have so much time, I mean, to think about how to manage water, because water, in a way around, I mean, it's too much, it's too little, it is not as we expect to be, and we are basically responsible for this. So it's really time for action because the cost for no action will be unbearable, but we have the tools, the instruments, we have enough knowledge in order to change our capacity of management of water. Any other question?
I would like to ask the water company ADAP. My name is Kolifetis from company Halcor. I'm environment manager. And I would like to ask what is the force that moves ADAP to make plans for reuse of the water? Is there any model, there is any data that they are using and justify the investments for the reuse of the water?
So, thank you very much for the question. I saw you earlier at part of all our projects, because we follow a quite careful approach. Part of our project is a feasibility study, which will scrutinize all the details. We have a market investigation, we have a tariff investigation, and it's not easy, it's going to be difficult because as previous presenters saw, we know all, the legislative framework now is a little fluent, things are changing. So we are optimistic, we can't be left behind. It's a choice, let's say. We would be glad to do it in our existing infrastructure, but as you see, the existing infrastructure geographically has certain limitations. In East Attica, it's areas which still have an agricultural value, and as a political and as an environmental choice, we do promote water use for irrigation for aquifer recharge. But we still have to be realistic. As you see, we build great pipes, great outflow pipes, which will cost a lot. We can avoid it. We must be careful. Hopefully it will be a model to use. Because EDAP is so big, it can't fail. We must do it carefully. That was our main approach. Hope I answered.
Any other question from the audience? Johannes.
Thank you. I have a question regarding the sewer mining aspect from ADAP. It was very interesting, and I mean, we have been also trying this in, let's say, smaller scale, with nature-based solutions, treating it, settling it, and then have a nice green wall screening the city while doing so. And there is also this new, I don't know if you're aware of this Greening Athens guideline, just developed by Lenio Mirivilli and the former vice mayor and so on, and Arch Rockefeller Foundation, who was paying for that. And it gives a nice background. So when you talk about sewer mining, have you considered these nature-based solutions approaches as well? Is this something that you will follow up with?
Close collaboration with Lenio Mirivilli, and we follow all the directives and instructions that we actually, some of them we have input also in their research, you know, and we get the new guide. We got it about the facts, and we trying to incorporate as much as possible in our project.
Thank you. That's very nice to hear.
Perhaps an additional comment on this. So as we said, the sewer mining technology is a very particular, let's say. When we talk about sewer mining, we don't talk about the concept, but a very specific type of technology. Actually, it would be very interesting if you visited the case that I mentioned as a potential water-oriented living lab. This is in the plant nursery of the city of Athens, which is a really beautiful place now that it's partly irrigated by this reuse. So it is the main intention was to keep the treatment part as compact as possible, because we were always thinking about irrigating green spaces in small parks, you know, regreening Athens and so on. And Lenio has been very active in shaping this in terms of the policy. I remember her even at the very first meeting of the community of practice in Attica. So the treatment part, I would say, in this particular instance is not an NBS per se. But of course, the idea is that this reused water, since it allows further irrigating urban green spaces, links with NBS and ecosystem services within the urban environment. So we've been working very much with that, and Lenio, of course, I think she's still the chief heat officer in Athens. So this part of microclimate management is close to her heart, and this is a very tangible ecosystem service from the sewer mining application.
It's part of the guideline.
Yeah. Indeed.
So one question, since we're talking about the sewer mining, the final step is reverse osmosis. That I saw there. Reverse. MBR, and because it was on the slide also reverse osmosis, or it's not not in the sewer mining, but on the upgrade of the sewer mining. Do you have problem with salts that
No. The RO was a potential upgrade indeed, but we only used it in the very initial TRL of the technology, where we installed a very preliminary, let's say, instantiation of this, Under the DESCENT project, you remember that we had two options, because we actually we were working together also with Danos and Kostas from the lab, and at the time we were setting up the system and we didn't know, whether we would be able to achieve with an MBR the qualities and so on. So we had, let's say, a bit of a testing. But then it turned out that it's fine. So in the real-world application that the tree nursery is, we just went with a simple technology. Now the next challenge, and this is what was pointed out, is that, of course, since energy has gone through the roof, it has always been an important part, but now it's a showstopper. So the idea is that in the next stage, which is even further away from, further into real applications, which is the Markopoulou case within the Impetus project. This is a climate adaptation mission project. We will try to be as energy neutral as possible. And this is a big challenge, I have to say. Any ideas on this would be most welcome. Thank you.
If I can just add an idea more on sewer mining. Of course, the idea of making MBS not the receiver of the irrigation water, but the treatment stage per se. In city center, it could be difficult. You have to play a little bit with multi-purpose design of big parks, and you told that is not possible. But there is also the other connection with water, food, energy nexus. Because unluckily, from a certain perspective, we have centralized our systems, and we are bringing all our resources in a single point, and it's not evident that in that point you need that water, you have to pump back. But we can view the existing network as a sort of cardio-circular system in our case that is bringing the resource where we need it. Can we imagine to take the water when we need, treat with an MBS, saving energy, and maybe irrigating where agriculture is requiring this water with fertilizers? We have to think about it. It's a possibility, but keep in mind that MBS is not only the receiver, but can be the treatment part of the story if you have enough space for doing sewer mining. So try to unlock this idea that sewer mining is only related to very high-tech technology, because otherwise this energy consumption became tricky for sewer mining concept.
We have also, I didn't show it because I was trying to be as brief as possible, but we are also considering putting small tanks in order to get water and trying to use it when, and so, I mean, we are but we have to take it slowly to the next level. It's not something that it can be done easily.
And indeed, just to, as you were talking about, another aspect of NBS that we are considering is NBS not in the treatment part, but in the storing. So the idea of aquifer recharge and recovery that was mentioned at a larger scale earlier on, it still applies here. I think Evie was involved in the subsoil project where we piloted this type of technology. We weren't doing sewer mining at the time, but we were thinking about the groundwater as a very flexible NBS storage unit. So we are now combining this, let's say, this idea with the sewer mining and indeed the large-scale implementations in Impetus. Actually, the entire system, the East Attica sewerage network, considered as a circular economy machine, let's say, is also part of the Impetus project. Actually, I was, when you were presenting, I was looking at everything thinking, well, actually, this is a large-scale climate adaptation solution, should be considered at a regional mission type of, and we are together, of course, considering this in this context. So we, in this Impetus project, because it's a mission, as Evie said, this is higher TRL, larger scale, we are pulling everything that we have learned over the past several years together as much as possible, from the large scale to the sewer mining, from NBS as groundwater to treatment and so on. And also digital twins, where's George, into one thing, try to see how much impact we can have at the regional scale. So we are developing a digital twin of the region of Attica to look into.
Let's have a final remark from Evi before we close.
Not so much a remark, it's also a question for ADAP. You mentioned some cost comparison of treated wastewater as compared to available water for reuse. I was wondering, the cost that you want to reach, is that for the whole treatment or for the additional treatment that is required? Because in any case, we'll have to treat it in a certain level, and then with the new directive, probably that level will be even stricter. So we need to be comparing same thing. So in my view, we should be comparing the additional cost of treatment.
No, I was not comparing. I was comparing irrigation water, and I was comparing with potable water that we are actually now use for irrigation purposes. So now we have a perfect, excellent water that we use it for irrigation. And because we are a company that has a social profile, we are charging even less than the potable water. And so that's our major problem.
But okay, so also
because this is an excellent water, you can drink it. It's not for irrigation purposes. It's not coming out of metamorphosis or these wastewater treatment centers. It's just from the main water supply system. Yes.
No, I understand. But then the wastewater, one would have to treat it to a certain degree to comply with the legislation, maybe not now for the smaller areas, but in a couple of years. And then, in my view, one should be comparing the extra treatment cost, because the first treatment would need to be done anyhow to comply with the wastewater legislation. And then the other issue is whether the irrigation water pricing is taking into account all the costs as foreseen by water legislation, whether it takes into account, because maybe there will be stricter reinforcement of water policy in the future. So the irrigation water would need to go up. I'm just saying this as, let's say, suggestions for to take into account in
a policy for us is to stop giving. In a certain point, our intention is to stop using potable water for non-potable uses. I mean, this is what we want to do, because we want to save good water for drinking water. And so that's why we are trying to develop projects that involve reuse of water for irrigation. Okay.
Thank you very much.
So thanks everybody for their participation, and particularly the speakers for the presentations. Food is served on the side, so I hope there is still left. we're late. So thank you very much, and particular thanks to Andrea.